रख सामने रख। Hello students, now we start about to discuss continuity. Continuity is based fully on limits. If you have clear knowledge on limits, then you can very easily understand continuity. If any function's limit at any point exists and is finite, and if also the function's value at this point f is also finite and equals to the limit, then we say that at that point the function is continuous. So I think this is clear that the limit must have to exist and the function's value at that point must have to exist and both have to be equal. Then we say that the function continuous at that point. Continuous hold if and only if the right hand limit of the function and the function's value at that point all are equal, then in short we can say that the function is continuous at that point. So I think this definition is clear. Now we'll go in another topic. Note: if fx is continuous for every value of x can take any value from an interval, open interval AB. You can take another. You know that if a Cartesian plan is the x-axis, it is a y-axis. You can take AB, any interval AB, and x can take any value from this, and the function, uh, function y equal to fx also is continuous throughout this interval, then we say that fx is continuous through this interval. If anywhere there is a point of discontinuity, there is any point defined that it is not continuous, then we cannot say that the function is continuous throughout the interval. It must need that at every point of in this interval of x, fx should be continuous. No point of discontinuity can occur. So this is clear, I think. Now we go in another topic. In what I have drawn in above, this is drawn in below also, a two-dimensional figure. You can also draw three-dimensional figure through more independent variables, and taking one dependent variable, you can draw three-dimensional figures also with same definition also. Now if fx is not continuous at a point, then the point is called point of discontinuity at that point. Means if x equal to a is the point where fx is not found continuous, means the condition I have said earlier is not satisfied, then the point is called the point of discontinuity. So other points except x equal to a, it may be continuous, but at that point it is point of discontinuity. One point of discontinuity does not show that the function is not continuous on the other points. Just at that point this is discontinuous, but in other points it can be continuous. Should be remembered. Now we need to remember more things about continuity. Different classes of discontinuity. Discontinuity can be of different classes, like if right hand limit and left hand limit not equal to, if it does not equal the right hand limit and the left hand limit, then what will be? Then fx is said to have an ordinary discontinuity. If this case happens, then we can say that the function is said to have an ordinary discontinuity at point x equal to a, because it is the limits are taken at a point. So the ordinary discontinuity we found at x equal to a point. Note that in this case fa may or may not exist. It is not related with the fa, means function's value at the point of a. Just right hand limit and left hand limit is not equal to a, not equal, then we directly say there is a ordinary discontinuity. It does not related with the fa. Fa exists or does not exist, it does not matter. It is also one topic that it can happen only one of right hand limit or left hand limit exist, and fa also exist. Just right hand limit exist or left hand limit exist, just one of them, and fa also exist, and which exists is equal to this function's value at that point. So such kind of case can be given. Such case can be given through an example. Take this function f2 plus e to the power 1 by x to the power minus 1. Its right hand limit, you can see that limit if x zero plus means right hand limit at the point 0 and the left hand limit at the point 0. Both have values 0, but the right hand limit have the value 0, but the left hand limit at the point 0 is coming 1 by 2, means both are unequal. If is a orderly discontinuity at the point x equal to 0. It is a very good example. You can look it clearly. Now, important thing is that fx is undefined on one side of a, let for x less than a, if a right hand limit of this function exists, and I have already said one side of the a means x is undefined fx. If you draw the Cartesian plan, then one side means let this is the point x equal to a. This one side is left side, this is, and this is right side. Left side it is undefined. In right side it is defined. Then what will be? And we think that the right hand side where it is defined is the limit also exists. Then what will be? Then is equal to fa, means the function value at that point, which also exists and finite. We say as a special case. If such kind of case occur, then we say this is a special case where one side totally undefined and one side is defined and equal to the function value at that point, where the point is under consideration, which left side undefined, right side defined, or the right side undefined, left side defined. Then such kind of, and if also exists and finite and equal to the defined part. So then we say it is a special case of fx. Now we will go in second case. In second case, such kind of case happen. Right hand limit, left hand limit are equal, but not equal to the function's value at that point, where fa exists but not equal to the right hand limit or left hand limit, or fa is undefined. The both case can happen. Then fx is said to have removable discontinuity at x equal to a. Means the limit exists but the function's value may exist but unequal, or does not exist, or undefined. So such kind of discontinuity at that point, I will say it is a removable discontinuity. Remove this. It is possible to remove the discontinuity. That's why it is removable discontinuity. How can it be? Can it be such kind of discontinuity removed? Then take an example: x square minus a square by x minus a. It is totally undefined at x equal to a, because in the denominator there we will get 0. That's why it is undefined at the point a. So the right hand limit and left hand limit, what will be? We can cancel x minus y, x minus y, x plus a. It will be 2a. So the limit exists, but the point at the point, the limit function at that point is undefined. So here it is a removable discontinuity at the function has a removable discontinuity at x equal to a. So so we can properly define this, then we can remove this discontinuity very easily. Here the function can be written x square minus a square, x plus a, x minus a, and in lower x minus a. If we, since x minus a, take that x not equal to a, x not equal to a, then is x not equal to a, then it can be very easily removed. But if x equal to a, it cannot be removed. So there is not given the removable procedure. I will discuss later how can the discontinuity can be removed. Just you know that I am just discussing the type of discontinuity, and the removal procedure I will discuss in later videos. So we will going through in that topic. If fx equal to 1 and x equal to a, then fx is equal to fx equal to 1 whenever x equal to a. If x takes value a, then fx value is 1, and when x not equal to a, then fx is e to the power minus x minus a to the power minus 2, and this function is defined as in this way. Then what is the limiting value of fx? You can solve this, you can find 0, and fx is 1. Here fx is defined, there fx is not defined, but here fx is defined. But you can see that the limit and the function's value at that point are unequal. So here also the discontinuity is removable discontinuity at x equal to a. Both cases, both examples are important. Please try clearly understand that. Now, note a function which has a removable discontinuity at that point can be made continuous, thereby suitably defining the function at the particular point only. I have really discussed that such kind of discontinuity, removable discontinuity, can be removed very easily by defining the function in such a way that the denominators which can be 0 after putting the value at that point. So after putting the point, so we have to remove such kind of discontinuity. We need to redefine this function in such a way that it can ignore to be undefined or to be unequal. So this is another procedure I will discuss later. I have already said. Now I just marking this that it can be removed. That's why it is a removable discontinuity. And this type of discontinuity, ordinary discontinuity or removable discontinuity, are said simple discontinuity. These are simple discontinuity, just ordinary discontinuity and removable discontinuity. Now 3 of one or both right hand limit or left hand limit tends to infinity, plus infinity or minus infinity. Then fx is set to a infinite discontinuity at point A. Means either one right hand limit or left hand limit, or both the right hand limit and left hand limit tends to infinity, not undefined. Clearly written, not undefined. Undefined is another thing. It is infinity. Infinity is also a defined part of mathematics. Infinity is also a defined part of mathematics. Undefined means truly undefined, which cannot be a part of mathematics. But infinity is a part of mathematics, and it is defined that it just tends to plus infinity or minus infinity. So it is called infinite discontinuity at A. Hence fa may or may not exist. Here fa is not related with the fa may exist or may not exist, doesn't matter. Just one or both should tends to plus infinity or minus infinity. Take an example. Fx is equal to e to the power minus 1 by x minus a. Limit of if the left hand limit you take, it is infinity, then fx is a infinity discontinuity at infinite discontinuity at x equal to a. Just one limit, left or right, if tends to infinity, then it is infinity infinite discontinuity at that point. You don't need to prove both the limits needs to tends to infinity. Just one, if fulfills to tends to infinity, then you can say it is infinite discontinuity at that point. Now we will go another topic. Any point of discontinuity which is not a point of simple discontinuity or nor infinite, means I have said ordinary, removable discontinuity, already infinite discontinuity. If any point of discontinuity does not fulfill such kind of conditions which I have already discussed, then such kind of point of discontinuity is called oscillating discontinuity. Oscillating discontinuity, this is another type. If such kind of conditions does not hold, at such a point the function that the oscillating discontinuity happens may oscillate finitely or infinitely, and does not tend to a limit, just tend to plus infinity or minus infinity. Just take an example: fx sine 1 by x oscillate finitely. How can we understand that it oscillates finitely or infinitely? Can you distinguish finitely or infinitely? One point is to remember that 1 by x at this point x equal to 0 is fully undefined. So if you go the before conditions of ordinary discontinuity or removal discontinuity or infinite discontinuity, if we cannot fulfill the conditions to ensure that you can assign such kind of continuity it holds. Actually it is fully different, but our question is that if such kind of conditions does not hold, then if it is a new type, it is oscillating discontinuity. So how can I understand that it is finitely oscillate or infinitely oscillate? One point is that sign value of any term is you know that sine of any angle 1 by x, if when we will take it x tends to 0, then 1 by x just being a very huge number. When it is very small to tends to 0, then sine of this value will be very large. So but sine is bounded function, minus 1 less than equal to sine of x less than equal to 1. Sine x always bounded. So x for all values of x, it does not matter what is the value of x. So if you will not put x equal to 0, which is undefined, but approaching to 0 values, then you will get a bounded or finite oscillation sin x. But in this case here sine 1 by x minus a is finitely oscillate, but 1 by x minus a is not finitely oscillate, because 1 minus x minus a, if you does not put x equal to a, but you can take any kind of value of the neighborhood of a. If you take a here and a neighborhood like epsilon, then there is many and infinite points. That's why it is infinite points you will get here. That's why it is infinitely oscillate. This is the basic difference, and you will have to understand this, that it is being bounded because of sine, and it is finitely oscillates. It is also finitely oscillates, but its corresponding part, this is infinitely oscillates. So that's why one oscillates finitely, one oscillates infinitely. And this is also another example, x to the power n, x equal to minus 1. This is oscillates finitely because minus 1 is a restricted value. Minus 1, whatever value you give, you just get minus 1 or plus 1. Whatever value, two values you can just get minus 1 or plus 1 in whatever. But here if you take minus 2, minus 3, minus 4, and if you take n different values, then you will get many infinite values. If you minus 2, minus 4, minus 8, minus 16, minus 64, many infinite values. So it is infinitely oscillation. This is the basic difference you have to understand. In another video we will discuss properties of continuous function. So before that I must request all of you subscribe this channel. I'll try to clear real analysis very easily. And for another videos search for Math Dunia in YouTube. There are many basic knowledge videos I have already launched in Math Dunia in YouTube. You need to understand for getting yourself in more strong in mathematics. In my own experience, I have a lot of experience in this field. That's why I have launched these videos, and you also view all these videos in Math Dunia, just searching for Math Dunia. Thank you very much, and learn more. Share with your friends, practice more, and think mathematics very easy.